All right, so we're picking up on number 10, which y'all are already going to have this picture drawn because, did it the other day, but the shortest fence. A 216 meter squared regular pea patch is to be enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence? How much fence will be needed? So we have an area, 216 meters squared. And then we have this lovely patch here with another fence down the middle because we said parallel going the other direction would not make sense or be wise because, that would be even more fence. So we know that area is equal to length times width, and that's equal to 216. So we've got I'm just going to do width going this way and length going this way, but it doesn't really matter anyways. So the perimeter, meaning the amount.
Computer lab, so I'm going to go see if I can sit in this bedroom.
Okay, that's fine. I forgot they were going to be in there. The perimeter is going to be 3L plus 2W because we have to also account for this piece here in the middle. So I'm going to get one of these variables by itself. So W is equal to 216 divided by L. Can you get the door, Nathan? Thanks. They're going to irritate me. All right, so now I'm going to use this in this equation over here. So we have 3L plus 2 times 216 divided by L. Now, I'm going to write this when I multiply this through as L to the negative 1 so that I'm not dealing with a fraction. Because what am I going to be doing next? I'm going to be taking the derivative. So I'm going to write this as 3L plus 432 L to the negative 1. So now the derivative, P prime, is going to be what?
3 plus negative 432 L negative 2.
Yep. Now what?
Now equal to 0.
Equal to 0. I've got negative 432. L to the negative 2 is equal to negative 3. Divide by that. So L to the negative 2 is equal to 3 over 432. The negatives cancel. Now, this is L to the negative 2, right? Which means 1 over L squared. Right? So since I have that on the bottom, I can flip both fractions over. So I'm going to end up with L squared is equal to 432 divided by 3, which is a lot nicer to work with.
And then square root.
Square root. So L is equal to the square root of 432 over 3. Now, fun fact, this 432 divided by 3 is, this is actually a perfect square. It doesn't look like it at the moment, but it works out nicely. 432 divided by 3 is 144.
Wait, I put that in wrong. I was like.
And what's the square root of 144? So the length is going to be 12, and it was in meters, so I'm going to put that on there. So now I'm going to go back and use this equation up here and find W. So W is 216 divided by 12.
Which
18. So these are the dimensions, okay? 18 by 12 is the dimension of the patch, but it ultimately wants me to find how much fence is needed. So, aka, what's the perimeter? So we got to plug into this equation here. So P is equal to 3 times 12 plus 2 times 18. So the total amount of fence needed is what?
$72.
72. And I forgot to put meters on the width there. And meters.
I did that in my head.
Good job.
Sometimes
I really wondered if you were putting in your calculator why it was taking you so long to say it. I was like, oh my goodness, you should be able to type faster than that. And then when you said you did it in your head, I was like, okay, that makes more sense. Outside? Oh, yeah. I know, I was a little scared the AC was going to come on. That's why I've left the dial so far over, because I'm like, when the AC comes on, it's going to freeze in here.
It's such good tennis weather today.
It is. Honestly, I walked outside earlier, and I was like, this is really nice weather. Like,
would
I could
go-
play tennis outside in
I
this.
would go take my boot off and play tennis. I would. Well, your hair.
All right. The next problem is going to be kind of similar to the problem we had at the end of last section, I think it was. Yeah. What?
Like local max and
Sort of, but motion and finding velocity and acceleration and stuff.
oh, okay.
That's what I meant. So 14, it's a vertical motion problem. The height of an object moving vertically is given by S is equal to negative 16t squared plus 96t plus 112. So this is our position function, right? So this is a 3-part problem. And this is with S in feet and T in seconds. So, you know, the norm. Find the object's velocity when T is equal to 0. So that's going to be the first thing. That's going to be part A. So velocity when T is equal to 0. It's basically initial velocity. Then we're going to be finding part B, the max height and when it occurred. And then lastly, the velocity when S is 0. So when the position is 0, what is the velocity? So, it's a little different than what we were doing, but kind of similar in the sense of like how we initially set it up. So I want to find velocity. So how do I find velocity from position? Yep. So the derivative of this would be what?
Negative 32t plus 96.
Okay. Now, I want it when T is 0, so I'm going to do V of 0. It's negative 32 times 0 plus 96. So that means that the velocity at T is equal to 0 is 96 feet per second. So that's part A. Part B, if we're trying to find the max height and when does it occur? Now, from physics class, it requires you to know a little bit. At the max height, what do we know is true?
Velocity is 0.
Yes, velocity is 0. So what do you think we might need to do? Okay, so set the velocity equation, okay, equal to 0. So I'm going to have the negative 32t plus 96 is equal to 0. So I'm actually going to find this stuff in the opposite order. I'm going to find when it occurs first, and then I'm going to find the max height because that's just the way that it's going to work out, but that's just the way that they write it. So negative 32t is equal to negative 96. So t equals 3 seconds.
So it occurs at 3 seconds.
Yes. The max height is occurring at 3 seconds. Now, I want to know what that max height is. So what do you think I might need to do now?
We plug that into the original.
Yep, I'm going to plug this value into the original, the position function, because that's going to give me the position at time t is equal to 3 seconds. So I'm going to do it this way. S of 3 is equal to negative 16 times 3 squared plus 96 times 3 plus 112.
I got it. 256.
256. So 256 feet is the max height.
I don't like using feet anymore.
Because you're so used to meters per second.
Meters per second.
Yeah, I know. Honestly, it's kind of annoying because you go back and forth, and then there's a lot of years that people put the wrong units on something, like when they're in calculus, because they're so used to physics units. They're like, wait a minute, this is not right.
Why does calculus have to be so weird?
All right, C. Oh, I was like, what? It's velocity when position. Okay, so it says S, but when position, so S is equal to 0.
So, do we have to put in 0 for position and then take the derivative of whatever that is?
Not exactly. So we're gonna set the position function equal to 0. So we're gonna have 0 is equal to negative 16t squared plus 96t plus 112. And we're gonna figure out at what time is position 0. And then we're gonna be figuring out the velocity at that point. So basically, when the object hasn't moved, what's the velocity? Which is kind of a weird thing to think about, but more instantaneous velocity in a sense. All right, so how do I solve this for t?
Well, we should take something out.
If something can come out, I would take it out.
Take something. Take like a low key. Take
Take
what's
the
that?
16 out.
Yeah, I was about to
Okay,
say.
yeah, 16 can come out of
I
everything.
had to make sure it worked.
Yeah.
Yeah. Well, that's why I say always start with whatever the term in front is. I'm actually going to take out a negative 16 to get rid of the negative in front and change the other stuff to negative. But that way it just kind of eliminates that extra factor. It'll make our factoring easier. And it's just going to go away. But I'm going to write that we're taking that out. So that's going to leave us with t squared minus 6
Yeah.
Yeah.
plus, that must be 7. Nope, minus 7. Yeah, okay. So then this is going to go away because dividing 0 by that, it's just gone.
So now we can factor.
So now we can factor this, and this is a lot easier to factor, right? Not that I couldn't have factored here, but it's not pleasant.
So negative 6 and negative
So t minus 6 and t minus 1. So that means that t is equal to 6. It's not 6. Because if you FOIL that back, it doesn't work. Factors of
Oh.
7 that add up to 6.
Oh, factors of 7 that add up to 6. Oh, that's right. I did it
Would
backwards.
it be 7
So it would
and
be-
negative 1, or negative 7 and positive 1?
Negative 7 and positive 1, yes.
I always do it backwards.
I was looking at it and then I was like, wait a minute. So I was foiling it back and I was like, that doesn't work.
It doesn't work.
So that means t is equal to 7 or t is equal to negative 1. But can we have negative time?
No. So it's not equal to negative 1.
Can't have negative time. So that means that at 7 seconds, the position is 0. I don't know if that means there was negative position at some point or what, but anyways. So now we plug this number into the velocity equation. So we'll have v of 7 is equal to negative 32, not 32, 32 times 7 plus 96.
Yep.
Negative 128.
Feet per second. Should we be alarmed by the negative?
No, because it's velocity, so it's a vector.
It's a vector, so it's just telling you a direction. Which tells you it's moving which direction?
South or west?
The
Left.
This way.
Yeah.
Or
Left or
this
down.
way.
Yeah. Depending on what the situation is. Sweet. All right.
What? Where'd you go to lunch at?
So actually, Thomas is actually pretty good. I had an appointment at the post office.
You had an appointment at the post office?
Yeah, post office.
You said you had an appointment at the post office or and the post office?
At the post office.
Oh, okay. I was like, wait, what? It's like you did a lot in that amount of time.
Right.
All right, this next one is going to be a little long. There's a picture drawn in the book for you, but I'm going to draw it so that way I can write all over it. So you might want to draw it so you can write all over it also.
Love it.
All right, designing a box with a lid. Okay, so think of like a shoebox that the lid is going to fold over onto it. Okay, this is the visual that I'm trying to get you to have right now. Okay, not like a box with like the lid separate, like the ones where it
Yeah.
folds back. Okay.
Yeah. We got it.
All right, a piece of cardboard measures 10 inches by 15 inches. Two equal squares are removed from the corners of a 10-inch side as shown. So I'll draw that to you in a second, for you in a second. Two equal rectangles are removed from the other corner so that the tabs can be folded to form a rectangular box with a lid. All right, the black is going to be folds, and then the blue is going to be the like outer edge of the box.
Wait a minute, you said black or the blue or the folds?
Black is going to be folds. Like in the book, it's dotted, but I'm trying to make it so you can see it. Alright, so this is the base. This is the lid. Now, this isn't going to be perfectly to scale, obviously, but just... Do you need a pen? You got one, Josh, or do we need to give him one? Alright, I'm not going to draw the little lines on this side, but I just wanted you to see visually what that's doing.
Wait, what is black?
Black is like the folds.
Yeah, I'm just trying to see if that
Oh.
over there is black or blue.
Black, this line is black because it's like the lid folding up.
Oh, okay.
So this is another multi-part question. We're not going to do part B, but we'll do C and D. Well, along with A. Anyways. So the first thing is going to be writing a formula V of X for the volume of the box. So in general, what is the volume of a box? This is an easy one.
It is. Volume equals. Wait. Side.
I don't know what you said.
He just said side. Do you need to phone a friend? That's what I had to do in college algebra today, or yesterday.
Josh, what's the formula for a box?
I would phone Christian, not phone me.
Stacy, what's the volume for a box?
You have 2 other classmates you can phone a friend from.
I'm not gonna.
Ethan's laughing, so he must know it.
I think isn't
Yeah,
it
top.
Yes. Alright, so volume is equal to length times width times height.
Oh, I mean. I did. It's just like I needed a friend.
Another formula you need to know for the exam. You will not survive if you don't know these formulas. Alright, so what is my length?
15.
Of the box. AKA, what's this length right here?
Eh,
7.5.
Close.
7.3.
Okay, let's start with our width. Actually, let's go really easy. What's our height of our box? When you fold the sides up, how tall is the box? It's not a number. There's only one thing it can be. X. Okay. So height is X. I need length and I need width. Okay, the width of the box. Going this way. What might the width of my shoebox be? Not the cardboard. I cut 2 pieces out of my cardboard. I know how big the cardboard was.
2x.
X.
Almost. Yep. Say it again.
I was giving it to Nathan, but it was
10
10 minus 2x.
10 minus 2x. Thank you. 10
Nathan
minus
really needs it. You gotta understand.
2x.
And I really need it.
Nathan needs it more. Have you seen him?
Now, what do we know must be true about the top and the bottom of the box?
It has to be open.
The same.
They're equal. Why?
Because that's the definition.
Because it's got to do what?
Open and close.
Close. Okay? So, that means that with the sides, okay, I can imagine that this is one piece, okay, and that this is the other piece. So, I would want to cut this piece in half, okay, to find that part. So, half of that, Nathan, is
7.5.
7.5. Called on you because you said it earlier. But I have to still take a chunk out because I have cut what out of that piece?
Yeah.
I've cut an X out, so I've got to subtract off an X. Are we tracking?
I guess.
Sort of? Kind of? No?
Like,
Good enough.
I'm being pulled along, but like tracking.
So we're just gonna like solve A and plug it in.
Sort of. I haven't written my equation for volume. I've just found each piece so that I can write my equation for volume at this point. I haven't done part A yet. So now this is equal to 7.5 minus X times 10 minus 2X times X. But I'm not going to leave it like that. So what might I do? Mainly because I don't want to do a product rule.
I might distribute.
Oh gosh. Okay. So 75 minus 15x, right? Yeah. Minus 10x plus 2x squared, all multiplied by x. I'm going to combine this middle term when I do it to be negative 25x, just so we're clear. So this is going to be 75x minus, go away, 25x squared plus 2x cubed. That is my volume of the box. Yes. Tracking. Cool. Makes sense. We're good with the basic algebra. Okay, cool. So this is part A. Now, use a graphical method to find the maximum volume and the value of x that gives it. So get out your calculators.
Yeah.
I'm gonna bring you this one. I'll just talk y'all through it. Alright, so you're gonna put that equation in y equals.
So y equals 5 something.
Yeah, if there's something there, clear it. Stats people, if you have a stat plot on, clear it. We haven't done stat plots in a hot minute, so it's
I have a
probably
stat
not on.
plot so
So turn it
those
off. Huh?
Glad I'm not open.
I don't even remember the last time we used that one.
I don't either. It's been a
We're
hot
plugging
minute.
in that equation for v into.
This right here. Yep. Now, when you plug it in, you could have plugged in this original thing as well. It would have been fine, but I would just use this one that we found. And then once you type that in, you're going to zoom 6, zoom standard.
Hey yo. What is yours like, John?
It's a cubic function, so it should be going opposite directions on the ends. It's positive, so it should be going up. To y'all, it should look like this, I think. Like,
Zoom out, it's like that.
Oh. How do
Well-
you zoom out?
How do you zoom out?
can you not see that? Huh?
That's what I can see. You probably can't see that.
Okay, yeah, it looked like that.
Wait, how do you zoom out?
Zoom 0.
Zoom 0. Ethan, did you hear that? Zoom 0 if you want to see the whole graph, which you're going to need to in
Why
a
does
second.
It look so different.
Can you turn it around so I can see it? Okay. All right, so now part C. Okay, we're skipping B because B is the domain of the graph. Anyways. Find the max volume. Okay, so if you go to second trace, that should bring up a calc option. There's going to be an option for max min, so you're going to need the max one. You're going to arrow to the left of whatever that highest point that you can see is.
To the left of that?
Yeah. It's going to ask you, it's going to say left bound, so you're going to go to the left of it. Then it's going to say right bound. So you have to hit enter when you're on the left bound. Then it's going to say right bound. You're going to go to the right of that highest point, hit enter, and then it's going to say guess. Hit enter again, and it'll give you a max. Did we get an answer? Okay. What is the answer?
Do you put the X or the Y?
Well, I'm going to want both because I'm saying where the max volume occurs, but
Little I got it.
so Y is going to be the max volume, X is going to be what the X value is that we cut out. So you can tell me X and Y.
X is 10.
Josh?
Is there anything after that? I got 10.4.
You got 10.4? Ethan, what'd you get?
I don't know what I'm supposed to do. You said go left.
What'd you get,
Wait, what do you
Christian?
mean by like left of like the highest point?
Wait, don't say it, Chris. Can you walk me from the start?
Okay, you have it graphed, right?
Mm-hmm.
Are you zoomed out so you can see the whole graph? Okay, so wherever this max is, okay, I don't know what it looks like, but anyways, the max here,
Yeah.
when you hit second trace calc, there's going to be an option for max.
Second trace.
Trace is at the top, like the fourth button over.
Look at the top. Oh, yeah.
Count.
Well, calc is going to be what it, second trace is calc. Okay, so then you're going to hit max. So now it's going to put your cursor, there's just going to be this little thing that's blinking, that's flashing somewhere along your graph. Okay, you're going to move it so that it's on the left side of this top point here. And you're going to hit enter.
Oh, I was putting it.
Do you not know left and right?
Well, no, I do, but it's just like it goes. I thought the highest point was like the one going like this all the way up.
No. The highest max point. The other one's going to infinity. So then once you hit enter, it's going to be flashing again. You're going to then arrow it over to somewhere on the right side of this hump to get it over here.
I got it different.
And then you're going to hit enter again. So this was left. This was right. Then it's going to say guess. And then you hit enter again. And it should give you an X and a Y value.
Low key, I got like.
What'd you get, Christian?
96 and 66.
There we go. Okay. All right, so the max occurs when X is equal to 1.96. What are we in inches? Yeah, inches. And the max volume, so Y is going to be the max volume, is 66 inches cubed.
And wait, so X is max height? Is that what you said?
No.
What did you say?
X is the value that we cut out.
Uh,
So 1.96 inches is the value, like, is the height of it. Yes, it is the height of the box, but that gives us the max volume from that piece. Okay? So we found it graphically. Now we're going to find it mathematically. No. We didn't do part D yet. Part D. Confirm your result analytically. All right, so I need to confirm what I found. Okay? So to do that, I'm going to, anyone to guess?
derivative.
Take the derivative of my volume function. So v prime, so I need the derivative of this.
So 75 minus 50x plus 6x squared.
Okay. Any ideas on what I might need to do now?
Equal it to 0.
Sounds like a great plan. Equal it to 0.
So now, like, good factor.
Nope.
Factor.
Can I factor?
Quadratic.
Quadratic formula. That's not factorable.
Leaving. I don't want to.
It's been a hot minute for the quadratic formula, but it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So, now, remember, this is written backwards, so this is a, this is b with the sign on it, and this is c.
Oh. That's
Okay? So, I plug it in. So, I'm going to do negative times negative is going to be positive. So 50 plus or minus the square root of 50 squared minus 4 times 6 times 75 all over 2 times 6.
Yes.
And one could potentially give you a negative answer, and obviously that would be a problem, right?
Right.
Because x can't be negative. We can't cut out negative box. So this is x equals, so what do we get? What'd you get?
129. Hold on, wait. Hold that.
Is that what you got, Josh? Is that what you got, Ethan?
What do you say?
He said 129. The
For the,
facial expressions kill
For
me.
the radical.
For the whole thing. Or Nathan, was that just your radical or is that the whole thing?
The whole thing.
Let's do it.
For one of them, I don't know if this is right, but for one of them, I got 6.37.
Okay. So 6.37 is.
I got that
That's
answer now. I did something wrong.
That was-
Okay.
6%.
Is that the positive or the
That's the
negative one?
positive one.
Okay, so I'm just going to put a little thing over. So then for the negative one.
I got it.
He's got it under control this time.
Big traps.
1.96.
Would you look at that? What is that?
What is what?
1.96 and 1.96.
They're the same.
Yay! They
Like,
match.
what are you talking?
Okay, so we verified this here. Now, when we set this equal to 0 and solved, what do we call this?
Finding the
Nima.
What?
points.
Critical point. Oh, not the erase.
Can't write it.
This is a critical point. Okay? Now, I said if we had a negative one, obviously that doesn't make sense. But why does 6.37 not make sense?
Because that's
'Cause it's
more
larger.
That's larger than like what it can actually.
So if I cut 6.37 out from here and from here, and I add that up, it's greater than 10, right?
Correct.
So that one doesn't make sense for that reason. Okay? The box isn't that large, so this doesn't make sense. For us to have cut out 2 pieces of that from each side. Even from the one that's 15, that doesn't make sense because that's just shy of 13 and there would only be 2 inches left, which doesn't make sense. So the 1.96 one makes the most sense. So we basically just confirmed that's all we really were doing. But that way, if you ever are trying to figure it out, you can graph it and use the max min function on your calculator and verify it. All right, I have one more example, but I don't think we are going to get through it, so I'm going to hold it for tomorrow, and then we'll probably have some time to work as well tomorrow. I might do a couple more problems, we'll see, but I have one more that I definitely am going to do. Do y'all want any problems to go ahead and get started on, or do you want to just wait till tomorrow? Okay.
I won't. If I decide.